AP Cram, Calculus AP, Free Response Exam Review, Question 66. Particular solution to a differential equation. Consider the differential equation dy dx is equivalent to e to the y times 3x squared minus 6x. Let y equal f of x be the particular solution to the differential equation that passes through x is equivalent to 1 and its f of x value 0. All right, so this is what we have to do. We have to find y equals f of x, okay, the particular solution to the differential equation that passes through 1, 0. And this is way easier than it sounds for those of you who don't know what's going on. But for those of you who do know what's going on, I'll give you a moment to write out your strategy and your solution. All right, finding the particular solution is the same thing as saying fish out y and find what it's equivalent to. So the first thing we're going to do is perform separation of variables. So we bring e to the y over to the left-hand side and we multiply both sides by dx. So we divide both sides by e to the y and multiply both sides by dx. Now we have all our y terms on the left-hand side and our x terms on the right-hand side. Now the next logical thing to do is to perform integration to get rid of the derivatives. All right, so the integral of dy dx over the integral of dy over e to the y is equivalent to the integral of 3x squared minus 6x dx. Okay, so now we're going to perform integration to find the antiderivatives of both the left-hand side and the right-hand side. But note that what we can do is rewrite e to the y as e to the negative y and then perform u substitution where u equals a negative y and then du dy would be just negative 1, all right? And to offset that negative 1, we would have to write a negative sign out here, okay? That might be hairy. This step might be a little confusing for some people. Just take your time with it, look over it a few times, and then you'll see exactly what I'm talking about. So on the left-hand side, we know that the integral of e to the u is just going to be e to that thing. And remember, I said we let u equal negative y. And then when you perform u substitution, you have to find du in terms of the variable of integration, which is y, so du dy equals negative 1, and we bring that negative constant out here, okay? Now on the right-hand side, we just basically use the power rule that says the antiderivative of each term is going to be the term raised to the n plus 1 divided by n plus 1. So here our n is 2, so we're raising it to the n plus 1, that's 3, and we're dividing it by the n plus 1. So that's going to be 3 divided by 3, that equals 1. Here our n is 1, we're raising it to the n plus 1, so you raise it to the second power. And we also divided by the second 2. So we get a 3, right? So we subtract 3, and then we add a constant of integration because we're not finding a definite integral. Notice we didn't add a constant of integration on the left-hand side. That's because it's not necessary. Even if we did, we could subtract it and bring it over to this side, and a constant minus a constant would still be a constant. So speaking of constants, what we have to do next is use the initial condition 1, 0 to find out the value of the constant. So wherever we see an x, we plug in the value 1, and wherever we see a y, we plug in the value 0. All right, so negative e to the 0 equals 1 to the third power minus 3 times 1 squared plus c. All right, therefore, when we simplify everything, c equals 1, because on the left-hand side, anything raised to the 0 power is just going to be 1, and we simplify. So 1 to the third power is just going to be 1. A negative 3 times 1 is going to be 3. All right. And eventually you'll see that we get 1. So now we go back to the equation and we substitute 1 for our constant. And after doing that, it's time to solve for y. Therefore, this becomes e to the negative y equals negative x to the third plus 3x squared minus 1. That's because we divided both sides by negative 1 to get rid of this negative sign. All right, and the next phase is that we take the natural log of both sides to get rid of the exponent on the left-hand side. So we end up with negative y equals the natural log of negative x to the third power plus 3x squared minus 1. And if we divide both sides by negative 1, we find out that y equals the negative natural logarithm of negative x to the third plus 3x squared minus 1. All right, so this is basically our answer. And it's valid for x equals 1, wherever this term is greater than 0. Okay.